Start again. Welcome to the Fortress webinar, an introduction to Fortress ProNet, control stations and mixed I/O opportunities. Your presenter today is Rob Stark, CMSE, Fortress Product Director, and in recent months has overseen the development of our network and digital product ranges. So before we get started, there's a few housekeeping issues we need to cover as in every meeting. I suspect the majority of you are sitting at home or in the office, so you know where the restrooms are. We don't have any planned fire alarm tests here, so if you hear one, you might want to run outside really quickly. So, Rob will give an overview of Profinet and Ethernet over IP, and then discuss how Fortress can integrate both ProfiSafe and CIP safety to offer cost-saving installations to customers. Finally, he will offer up some new and exciting product ideas. I'm your host, a rather bad one so far, and my name is Malcolm Shah. I work closely with Rob and am involved in machinery safety standards development. The webinar is about an hour in length, maybe a bit less. If you have any questions, please ask them by clicking the Q&A at the bottom of your screen and typing your question in the dialog box. And please accept my apologies if we can't answer the question during this webinar. We were significantly oversubscribed for this webinar, but we will endeavour to answer questions by email if they're not addressed here. Webinar will be available to download within a few days, both in video format and as a PDF. And finally, we have a short pop quiz at the end of today's event, and this will be in the form of a poll. And that will be followed by a tiebreaker question that you'll be able to answer using the chat function at the bottom of the screen, but we'll explain that a bit further. So that's quite enough from me, and I'll hand over to our presenter, Rob.
Oh, thanks very much for that, Malcolm, in terms of, and also thanks very much for everyone else that's joined. Malcolm's just given that intro, but yes, as Malcolm said in the intro, we were actually oversubscribed today, so I can see that there's a little up to a maximum of participants on the webinar. But yeah, thank you all for coming, and we'll get started. As Malcolm said, we'll really look into some Ethernet communications. We do encourage you to use the Q&A. We will have a question session around halfway through, so in around 20 minutes. There's also the raise hand function and similar. If you choose the field, if you choose that you want to interact at any time, we might actually open it up. So if we all said now, if you could raise your hand within the webinar, if you're familiar with Ethernet systems, it might give us a bit of a show of who's familiar and who's comfortable with them. While you're doing that, I'll just talk through what else that we'll look at. We'll look at basically the Fortress Ethernet devices after going through a bit of Ethernet basics. It's really what I understand, so it is a bit of a dummy's guide. Actually, what's on the right of the screen here is an Ethernet connected Fortress device that's installed at an automotive manufacturer all around their weld cells. They were one of the first customers to really go for it, and it's really been this growth of value for our customers. So it will be worthwhile looking at what we can do regarding cost savings and what we can do around maximizing the functionality for some end users. And then, as Malcolm said, the last things that we'll discuss are control stations, customizable I/O blocks, and two-hand control devices with Ethernet connectivity. So to start, we'll basically try and make sure that everyone is familiar with Ethernet communication. It's used for a lot of things that we're interacting with daily. Everyone will be interacting with an MRP or an ERP system that relies on using huge amounts of data and transferring them correctly. Where Ethernet really comes in as an advantage, it's something called full duplex technology, where communication can be transmitted in both directions without really any negatives. It's not like a fax machine where you would have to put the phone down to receive a fax or put the phone down to send a fax. You can basically receive and send information at all time. All of the devices in Ethernet networks are uniquely addressable, and there's some real nice advantages that we can get there. Also with Ethernet, it tends to have some established standards and knowledge, and it tends to be really quite nice and scalable for the future. If anyone was familiar with technologies like ASI or ASI Safe, we actually see our customers, particularly in like the intralogistics industry, where they're building warehouses, and each warehouse is slightly different in size. They'll look to adopt a Ethernet-based technology opposed to an ASI-based technology, because they just view that Ethernet technology so much easier for them to scale between a small warehouse, a medium warehouse, and a large warehouse without making significant changes to their control systems. Where we see Ethernet growing in the future is that as we have more and more intelligent automation systems with data collection, it's increasingly important to have that ability to communicate large amounts of data at that field device level. It's probably what a lot of people refer to as that Industry 4.0, that fourth industrial revolution, or the Internet of Things. Fortress views itself as following along that path by looking at what we can do to integrate Ethernet technology. We've gone fairly rapidly from a company that provided mechanical products with some great advantages. It's a still great market for us for the applications where people want to reduce cabling by using mechanical devices, but actually where people are looking at transmitting data, they're going for these Ethernet connected devices that we'll get onto. In terms of, first of all, understanding a little bit of Ethernet, I think it's easy to confuse Ethernet with something that's used in the office. For those of that are actually interested, the first Ethernet protocol was actually invented by Xerox printers, so we will all forgive you for confusing it with something that may communicate to the printer. It's also worthwhile not confusing Ethernet and Internet. Ethernet tends to be this physical data link layer. It's the Ethernet cable, but Internet is the communication that happens across it. So Internet is actually the combination of an Ethernet cable and TCP/IP communication protocols. In terms of for automation, where it becomes really interesting in this slightly different level, is that we start to talk about these languages called Profinet or Ethernet IP that are dominated by some of the large manufacturers in the industry. The reason those are on separate devices, for me, it's all about walking into that crowded room with lots of people, and those people could be speaking your own language, or they could be speaking a foreign language. And in that large room, you'll always be able to pick out someone saying your own name naturally, or if you're on holiday and people are speaking French, you're usually able to pick up when someone's speaking, say, English, if English is your natural language. That's what we really view these Profinet and Ethernet IP languages as, is that they are a specific language communicated across this Ethernet cable. That means the communications for running machines don't get confused with the communications from someone in accounting sending something to the printer. What then becomes interesting for Fortress is that these Ethernet communications with the Profinet and the Ethernet IP languages can be used to communicate safe signals. What we mean by safe signals are signals that can be used in a risk assessment and be used as a risk reduction measure for safeguarding around a machine. So these can be emergency stops, it can be guard locking devices, guard switches, light curtains and similar. But if it's an Ethernet cable, we do really need to understand of how that we can make something safe communicated across that. So something that initially is confusing and was confusing for me for a long time before I tried to understand it was this thing called the black channel principle, where people start to communicate safe communication over an Ethernet layer. Basically, there's an additional protocol and an additional language landed on top of Profinet or Ethernet IP. This is known as the black channel layer or the black channel principle. The name of it all comes from the term black box that we're familiar with from the aviation industry. And in its simplistic form, it's basically a device that is reviewed based on its inputs and outputs and cannot be viewed internally. What this means for a communication system, hopefully the images on the right help, but this means that for Profi-safe communication, it's only ever communicated between the central controller, the PLC, and the device in back. You can't view that communication across the network anywhere else. All safety I/O within those devices, like an emergency stop or monitoring of machines, can be communicated across that black channel principle to retain its safe and its consistent communication. In terms of how it does that, it basically sets up a load of new rules and special checks that are put in place across that communication layer. They're in the table on that slide, but the way I understand it is that one of the methods of being able to ensure that communication is safe is that they'll attach consecutive numbers to the bits of communication that go across that layer. That means the first communication is communication 1, second is 2, and so on and so on. That means, because that relationship is agreed, that means when you're receiving messages across that, if you receive the messages in either order 1, 3, 2, you know, something that's come jumbled across that communication layer, or if you only receive messages 1 and 3, you know that a message has been missed. At that point, if a device is communicating safe communication over Ethernet miss a message or detect something that's a problem, it'll raise a fault to say, I can no longer keep my machine safe because I'm missing messages and I could miss maybe an emergency stop being pressed or similar. Hopefully that's an easy enough understanding. It's basically, like I said, a dummy's guide. It's the way that I've been able to understand it. And it is something that I try and use to rationalize it daily as we interact with these. Another thing I try and keep hand of is some network component definitions. We've already mentioned Profinet and Profisafe and Ethernet IP, but to break them down is that we view Profinet as a Siemens technical protocol for data transfer and control over a layer of industrial Ethernet. That communication protocol tends to be run by the Profinet Industry Society, along with Profisafe, which is that black channel principle over the Profinet network. For Ethernet IP, we view that as an ODVA managed protocol for data transfer and control of a layer over industrial Ethernet. And then SIP safety is that separate layer of communication where safety related functions communicate on the Ethernet IP network. In reality, some other manufacturers use those communication protocols with their devices. So you do see maybe an ON1 device or a SIC device also using those two languages, but we do view it as the big players pushing that communication as Siemens and Rockwell. Later on in this presentation, we'll discuss some other devices that hopefully you're all familiar with, but just to clarify, we'll discuss the Ethernet switches. Ethernet switches are very much like the internet modem I'm looking at in my current house right now, is that it's a switch used to connect multiple Ethernet cables to the same network, where devices are used to communicate to each other. We tend to see them inside panels and similar, where you have this bigger box that looks a little bit like your modem at home. I/O cards and then other elements of control systems, they're control panel components that process digital 24 volt, usually I/O signals, and they basically take those 24 volt signals and turn them into a language that can be communicated over an Ethernet cable. We then have I/O blocks, which are very similar, and they're machine mounted devices that connect multiple devices to one networked block via quick disconnects. So they tend to look a bit like a porcupine with lots of cables coming at the top. Those are some things that we'll discuss later. But before doing so, we'll just consider what does Ethernet connected systems look like when they're installed. We tend to see a couple of main topologies coming out. The first one being star, where you'll have that central Ethernet switch in the middle and you'll connect with one cable out to each device. It's really quite easy to administrate, and you can add and remove devices without affecting any other devices, providing you've got slots available within your Ethernet switch. No devices are linked to each other, so there's no interdependency between devices. And you can get some real favorable component costs on those devices connecting into it, because each of those devices doesn't have to do anything apart from receive and send its own information. It doesn't need to be a switch to transfer along to another device. Where we see linear topology is basically for those that are usually familiar with classic field bus systems, which connected it all in like a daisy chain line. With those, it's really around minimizing that overhead cabling, because you're no longer having to run every single device back to the panel. You're just running one continuous line between the devices, but that does require each device along that line to be a switch to take a data connection coming in over Ethernet and send out a data connection going out to the next device. Ring topology is then a variant of linear topology that we see, where it adds a level of redundancy for critical applications, where each device is still connected like a linear topology in terms of it goes into one device, out to the next device, but it forms a whole ring all the way around it, all the way around the system. That allows that if one device or one cable fails, there's redundant support. Each one of those devices is intelligent enough to know that if a cable breaks or a device fails, it'll send the messages round the other way around the loop, and it'll become a linear system with a break in the middle. That does require some special handling systems on the switches within the device to do that communication of sending it back around the other way around a ring. But luckily for those using Fortress devices, Fortress can support those ring topologies in both network protocols. That brings us nicely on to actually what does it look like when it's integrated in a Fortress device. Hopefully people joining this call will be familiar with Fortress devices, but a Fortress device looks very much like what's on the right there. That's a guard lock with an ergonomic handle on the guards and then a solenoid to lock the guard closed while the machine is operating. At the bottom of that device, we've highlighted out something called the ProNet pod. The ProNet pod is the piece of the unit that provides that network capability. It's the bit with the power connectors coming into the bottom. It's got a window for some dip switches for setting an IP address of that unit, and it's got push buttons housed in the lid as well. Where safety monitoring, like an emergency stop or the guard locked and closed signal, those are all communicated over the safety protocol, i.e. Profisafe or SIP safety. Fortress actually has external TUV approval to category 4 PLE for those safety communications within the Ethernet module. And we can support 3 dual channel safety inputs and 1 safety output. I've deliberately bolded that on the slide because it is something interesting for us to remember when it comes to configuring units. Typically, we see those 3 dual channel inputs configured as maybe the guard locked and closed signal as a set of safety switches as a safety input, an emergency stop as another safety input of knowing when that's pressed or not. And then we see that third one used for a bit of flexibility. Quite often it's actually used for maybe if they've got a robot and they've got it set in teach mode, they'll come along with an enabling switch and a live man's handle, and they'll actually connect that into the interlock device and then jog the robot with that live man's handle over the Ethernet network. That means that they don't need to put a separate IO point or a control panel for that temporary application of an enabling switch. They just connect it into the bottom of the interlock and then at the end of the process unplug it and move on. All of the other IO within a device, i.e. the push buttons and the monitoring signals that aren't communicated over the safety network, they're communicated over Profinet or Ethernet IP. We do see some customers just going for push buttons only and no interlocking device, and then those devices can be entirely communicating over Profinet and Ethernet IP with no ability to communicate safety. Hopefully that makes sense. Then, just as the last thing that we'll jump into before a few questions is around that once we've got this device and once we've got this understanding of topologies, we can start matching up of selecting Fortress devices to match those topologies. If we know a customer is going for a star topology, we typically might offer them a single connector for both power and for data. So that means that they only can run 1 cable. They're basically limited how many cables they can run to that device, and they can't do any daisy chaining. However, for those customers going for linear or ring topologies, we allow them to have 4 connectors at the bottom of the unit. 2 of those can be used for data, 1 that takes the data into the unit, and 1 that takes the data out of the unit onto another device within the system. The other 2 receptacles or quick disconnects at the bottom daisy chain the power through the device. So you can run 1 power cable from the control panel to the Fortress device, then another power cable onto the next device. You can actually daisy chain up to 8 Fortress devices in the line, but we typically see the most common applications being 4 or 5. The thing to consider there is all around voltage drop, because the more devices that you put in the line and the longer cable runs you have in there, the more voltage drop you will see. That bit around voltage drop tends to come up a lot of times, and it actually comes up again when we start to see this different types of customers selecting between 7/8 or M12 connectors. Hopefully everyone in the automation industry has got some familiarity with M12 and 7/8 connectors. I know that since I've worked in this role, I've learned a lot about cabling, more about cabling than I ever thought I would. But what we tend to see is that for customers looking to maybe look to buy a thinner and a cheaper cable, they might go for an M12 connector at the bottom of the unit. But for those customers that are considering, well, that actually in their system, if they're going to have voltage drop as a problem and they don't want to put in another power supply and they don't want to put in this interstitial control panel that provides more power to the system, they'll go for a 7/8 connector at the bottom of their Ethernet device. This allows them to run a thicker, albeit more expensive cable, but because that cable will exhibit less voltage drop, they'll actually save money overall by starting to reduce the number of additional power supplies and control panels in the system. As I said, we're just coming up to a few questions as we've just gone over the basics of some Ethernet and basics of Fortress devices. After the questions, we'll roll through a little bit more detail and a little look at some of the functionality that's possible. But at that point, Malk, have we had some questions? Oh, have I lost him? I can see in the chat some questions already.
Yep, so we have some there. So one of the questions that came up.
Hi, Malk, I can't hear you there. I don't know whether I've lost him. Hopefully you can all hear me. There's a few questions that I can see that have been posted in the chat. There's one to all the panelists, which is, can Fortress products work with Omron networks? Well, actually, interestingly, yes, we can work with Omron networks. Omron networks are one of the other manufacturers that we see adopting an Ethernet IP protocol. So both we have applications where we've installed with Omron safety controllers and SICK safety controllers, which have been available with Ethernet IP communication. Another question I can see in there from Derek is, does Fortress support PoE? Actually, we do support PoE. PoE is not typically a common application for us, but we do see it for a few devices. One of the most interesting customers that requested Power over Ethernet was where they were retrofitting one of their older machines for metal rolling with Ethernet communication, and they only had very, very small conduit to run cables to each device. So they couldn't run a power and a data cable through that conduit. They could only run one cable at a time. So they were a customer that elected to look at Power over Ethernet for doing all of that. We tend not to see it too popular based on the Ethernet switches that allow PoE being a little bit more expensive. So typically customers will weigh up the decision between a standard Ethernet switch and a Power over Ethernet switch, and maybe they'll adopt for a power supply and an Ethernet switch instead of a PoE switch. But those of you that do have a PoE application, do get in contact with us because it is something that we can support. Malcolm, Eric confirmed in the chat that he can't hear you. I don't know whether you've been able to fix your microphone. Go from there. I'll then look at one of the other questions that we've had in there. So, are the topologies dictated by the client, or can we recommend one depending on the application? That's an interesting question. Typically, we see the topologies are dictated by the client. The reason why is that typically they've made their decision on topology based on either their robots or their drives, or they've made their decision on their topology before they've got to the interlocking level. The thing that we try and offer is the flexibility to be agnostic between different types of topologies, so we can work with it whatever they provide instead of them having to focus down on one type of topology just for Fortress. This allows us to offer that flexibility. We've then got a few more questions, and I'm more than happy to answer the rest of the questions at the end, but in terms of tracking it on, we'll run through the next bit of presentation and then we'll come back to those questions, and by all means keep them coming in because we'll go through them at the end. The next bit of the presentation will get into a little bit more detail, and again it will be that level of detail that I can understand, so by all means treat it as a bit of a dummy's guide.
Before you start, I'm hoping everyone can hear me now.
I can hear you now, Malk, so I hope that we can hear you.
Yes, the internet's having a few problems this side of England at the moment.
Yes, I can see that Derek and Eric have both come in the chat to say yes, they can hear you. As I was saying, the next bit will talk about a little detail about how Fortress devices can be implemented, but it'll be at my level of understanding, so hopefully it'll be easy to understand. Basically, I imagine the Ethernet communication to look like a virtual terminal block, and I'll plug in different wires into different bits of the terminal block within the PLC, and that'll allow me to connect to the units. What this means is that we have the ability within every unit to basically wire into an input. So what we mean by an input is when a push button is pressed, we'll see that input signal go high, and then we'll be able to input into an output, which will be like a lamp. So when we send an output to the Fortress device, we'll see that light lamp up. As standard, every Fortress ProNet device is fitted with illuminated push buttons, and because there's no additional wiring required to illuminate those push buttons, each customer can really take the advantages of getting an illuminated push button as standard. If you're imagining a hardwired product, when you're putting push buttons in, if you're getting to the limit of how many cable or how many pins you've got left in your receptacle or cable, you'll start to make a decision to say, oh, I don't really want that e-stop illuminated, or I don't really want that push button illuminated, because it'll be pushing your cable costs up. But because all the communication is over Ethernet, we can allow all of those additional functions to pop in without any additional cabling costs once the investment's been made in a Fortress Ethernet connected device. The other thing that I find is an advantage that people often aren't aware of is that when we're looking at the safety inputs to a device, if we were doing it hardwired and I was wiring to this virtual wiring, wiring to this terminal block, because it's a safety signal and I want to have two switches on there in case one switch breaks, or in case that one switch welds closed or one switch doesn't operate correctly, in my PLC program, I would need to check between channel 1 and channel 2 on those switches, and I need to write an add-on instruction or something similar where I'm checking between those to check their synchronicity between those two. One of the advantages of using an Ethernet connected device that's got a bit more intelligence is that actually the synchronicity checking between the two channels, or maybe an e-stop. So an e-stop will physically have two switches, but the checking between those two physical switches will be performed by, the synchronicity checking will be performed by the Fortress device itself. This means for the PLC programming, it can be a bit more lightweight because they really only need to check one of those safety inputs going back to the PLC. They don't need to check both, and they don't need to have that check done within the PLC. So we are actually seeing a fair amount of controls engineers when it comes to whether they're up against it to write a program in a short amount of time, or they're trying to save a bit of money outsourcing an AOI, they'll adopt an Ethernet connected device because it'll make that PLC program a bit more lightweight. Another thing to consider is a bit of advantage when it comes to having this virtual wiring diagram that basically communicates all the information available within the device, is you get these additional bits at the bottom, which are called qualifiers. They did confuse me for a long time, but I've managed to try and rationalize it as they are basically a monitoring contact for the safety signals. So a qualifier should move with an e-stop. So if an e-stop is pressed, you should see that qualifier go low. That means the emergency stop has been pressed. If you see the, sorry, I've read that backwards. If that e-stop was pressed, you would see the e-stop safeties go low, but that qualifier go high to confirm that e-stop has been pressed. If that e-stop had a fault, you would see the safeties go low on that e-stop because it detected a fault. Maybe the two channels didn't move in time, but that qualifier would say low because it's not detecting that e-stop has been pressed. That would say that there's then a fault on those channels, and that means basically every emergency stop within a ProNet device can be wired like a monitored emergency e-stop. So when we're engaging with customers, we can say to them, well, in your PLC program, you can choose to wire it as a monitored e-stop if you'd like. You can choose not to. It's really up to you. You don't need to invest any additional money in buying a monitored e-stop or similar. So that can be another little bit of advantage. However, the real main advantage really comes down to these cabling runs. So because our connected interlocks in a ring or a linear topology provide the ability to daisy chain the units and provide that significant reduction in cabling, we can see cabling reduce up to 70% in some applications. I'm not sure what the percentages of what's shown on the slide, but on the slide is basically some screenshots of an animation we put together for one customer to allow them to present internally the case for Ethernet. In their previous arrangement, they had a hardwired interlock on the door, which had a 12-core cable going to a hand-built push-button box. And then that push-button box had a 25-core cable running back to the cabinet. And then when they were looking at an Ethernet solution, they started to daisy chain everything together. And what that meant is that they could incorporate all of the push buttons into the interlock device instead of building that separate control box. And it meant that the only cables running back to the panel were a 5-core cable to go into a power supply and the Ethernet cable that just plugs in with an RJ45 connector into the Ethernet switch. So they started to see a vast reduction in cost. The other things that we tend to see as well is people doing cost analysis of looking at hardwired solutions and Ethernet solutions. The next couple of slides start to demonstrate that. So one of the things I'd like you all to think about before is just get a number in your head of, if you're installing 10 interlock devices or 10 hardwired safety devices in a system, and each one was 20 meters away from the panel that they were going to connect back to, what would be the additional cost to installing those devices in a hardwired method? When we ran this presentation previously, we had people guessing maybe $8,000 or $10,000. But actually, if you start to map out what those costs are based on some list pricing available online and some manufacturer's part numbers, for those 10 interlocks, you actually see a $25,000 additional cost to get them to the point where they're installed, because for 10 interlocks, you've got to buy 200 meters of cable for the interlocks. You've got to buy 10 push button gate box enclosures to put the push buttons next to the gate to allow you to unlock it and reset it. You've then got to buy a 19-pin cable for that gate box. And then you've got to buy IO cards and control panel elements and power supplies to support them both. And you've got to buy a larger control panel. And it really is shocking of that You might be spending a certain amount of money on your interlocks, but by the time they arrive on site, you've got to spend another $25,000 just to get them installed. So when we talk about network functionality, we can start to look at an analysis like this and start to bring out really, well, what costs can we reduce by looking at an Ethernet solution? In terms of the costs that we can reduce, we can start to look at those inputs and output cards in the control panel, because we no longer need that Rockwell device that takes the 24-volt signals and send it back to the PLC. We can just connect to the network and send that back to the PLC. So that means we're reducing control panel elements, we're reducing the size of the control panel. And then for the gatebox enclosures, we're reducing the labor to build them, we're reducing the labor to punch them out, the purchase cost of the enclosures, because you can put the push button directly into the unit. And then we're eliminating that big cost on there, which is the 19-pin cables, by sending everything over maybe an M12 5-pin cable for the power and the data cable. And if you just look at what's highlighted on that slide, you can look at removing around $14,000 of additional costs in a network installation by replacing it with a unit with more functionality alongside it a bit. This type of calculation will always change for different applications, so you do need to be aware of different cable runs and different requirements will change, but overall there is a massive opportunity to look at how can installations be reduced in cost by looking at Ethernet solutions. Hopefully that makes sense. I'll stay on that slide just for a few moments while people digest it. I can see that there's a few questions come through in the chat that we'll get to at the end. The next bit of the presentation really starts looking at now that we've got this network connectivity as this ProNet option pod at the bottom of an interlock, how can we start leveraging it for other applications and other things that we can help our customers with? Well, what we can start to do is start responding to some of our customer requests. So customers and Fortress started to establish that a lot of the cost savings were found in the connectivity to that ProNet option pod. And we started to get those requests to use the Fortress module in their installations, even when there is no interlocks. And sometimes it was positioned alongside the interlocks. The image on the right is actually something developed for a tier manufacturer, where they created something that we call a split stack, where they split their unit into two modules. They had the module on the left, which contains the Ethernet communication, and then a standard hardwired interlock on the right. But what that type of application means is that they can change the interlock based on the application. They can change it to a light curtain if they wanted to have safety inputs and similar. And we start to call this range what we call network control stations. And those network control stations are something that's a really growing opportunity for us. And the thing that we'd encourage you is that if there is something we can possibly help with, reach out to your local Fortress representative to start getting engaged in this type of stuff. Fortress prides itself on offering this customized solution that'll suit exactly the customer's needs. Like I was saying, you can change that unit on the right, and you can start looking at how can you utilize the technical specification of the unit for different configurations. So we've had customers starting to look at maybe using even a competitor's interlock device into a Fortress network control station, or putting two devices into a network control station. The reason you can put two devices in there is because you've got the ability to use those 3 dual channel safety inputs. Those 3 dual channel inputs can be dedicated to maybe a central e-stop in the network communication, and 2 interlock devices connected via digital I/O QDs at the top. So in that image, we've actually got on the left 2 hardwired interlocks connected into hardwired QDs like an I/O block, and then the e-stop in the control station. In the middle, we've got our Atom switch, which is a RFID coded switch with OSSD inputs. In that application, you can actually daisy chain your Atom units, because we can support an OSSD input into the ProNet option pod. So that means that maybe on a metal press, you can have maybe 4 hatches down one side and 4 hatches down the other side, and daisy chain them back into the ProNet option pod. We're also shown on there our T-Guard range being used, where people like to configure it with push buttons and similar, and then put that on the gate, but then still have an Ethernet connectivity to those devices. And on the right is something that we've tended to see as well, which is where people have started to request an Ethernet enabled light curtain, where they've started to get to the point in their automated systems where, or their automation control systems, where every single device is Ethernet connected, but there's still a few sticky devices that are left where they can't find on the market an Ethernet enabled light curtain. So they start to approach Fortress to say, I really want to use this manufacturer's light curtain, but I need a way to get it over maybe an Ethernet IP connection. And we're more than happy to engage people on that. The product that we start to engage people on that with is what we call our customizable IO block offering. It looks very much like an IO block you might see from other manufacturers, but other manufacturers will want to sell you an off-the-shelf IO product, which is limited to pre-configured receptacle arrangements. Fortress offers the flexibility to take the existing digital IO devices and incorporate them into a Profinet or an Ethernet IP safety network. So we've seen where customers were using maybe an off-the-shelf IO block and then a lot of cable splitters or cable adapters to go between different sizes and different similar. And we've said, well, actually, you can reduce some of the cost associated with your additional hassle of wiring into that IO block by just buying a configured IO block that gets you set up for a direct plug-in. For that reason, we've incorporated M23 receptacles into control stations as well, where people wanted to maybe connect a 19-pin M23 cable into an IO block, and that's not something you tend to see available. Everything else tends to be M12 with maybe a 5-pin or an 8-pin. What we have on the right is actually where someone wanting to incorporate push buttons into an IO block because they were previously buying an IO block and then having to build a hand-built push button station alongside it to connect in. Well, we offered to say, well, actually, put the push buttons into the device, use the quick disconnects and receptacles on that device to connect to your control drive elements, maybe the brake or maybe the limit switch on the drive. You can communicate some of those over safety. You can communicate the rest over standard. You can maximize those 3 dual channel safety inputs and the other standard IO that's available. Our standard IO is actually extendable, so you can extend it up to having multiple connectors. We can actually support basically 40 extended IO within one single Fortress device. We do that by just adding another module on and making that IO block a little bit bigger. I can see a few questions have come in on that, so we'll capture those up at the end as people have started to offer some comments, because I imagine that's something new that you haven't seen before. The other thing that'll be new that you haven't seen before is actually an Ethernet two-handed control device. It's something, again, where our customers started to approach us to say, well, one of the only things left in my system is a hardwired two-hand control device around my press. Everything else is Ethernet. What can Fortress offer as an Ethernet control, two-hand control? Sometimes they were looking to remove that installation hassle. Other times they were looking to remove that big armored cable that was on the floor. So where they had two-hand control with push buttons, they maybe had a big thick cable and they needed it to be steel armored to make sure it didn't break when someone drove over it with a forklift. And then when it did break, it was only available on maybe an 8-week lead time when they always had to keep one in stores, and there was this big cost of keeping it in stores. But one of the advantages that they can go to, especially if they use a PoE device, is that they can just have one cable running to this Ethernet two-hand control. And then we still offer the flexibility to have that central push button arrangement flexible to whatever the customer's requirements are. So if the customer's requirements are to have a blue push button and a white push button, we can do that. In this scenario, they have an e-stop, a white lamp and a red lamp. We can engrave each of those lamps with custom engraving based on the situation that's happening in there. And basically, we're more than happy to get involved with replicating whatever standard or procedure that they want, but providing them something with enhanced functionality. Again, what we mentioned earlier is that the checking between the channels is done within the device, so you can get to see some PLC program benefits by reducing the weight of having to check between those two devices, because we will actually monitor a one normally open and a one normally closed switch on both of those black push buttons on both sides. So that means we'll be able to know when they're pressed and when they're depressed and communicate all of that back to the PLC. For those of you that maybe are interested in maybe looking at configuring it, we do have some part number breakdown available that's relatively easy to understand. This will be included in the presentation pack that gets sent out. But basically, you can configure your own by following the two-hand control part number, selecting Ethernet IP or Profinet, and then select whether you want it supplied with a mounting plate, with a pedestal, whether you want the cables routed from underneath the top or the bottom of the unit. You can have it mounted not on that pedestal. It doesn't have to come on that pedestal. It can just come on that top plate and be mounted on the side of the machine if the customer wanted to. And then you can start then to configure that middle central control option by selecting which push buttons that you want. As you can see on there, we can offer illuminated push buttons, select the switches, e-stops, lamps, and similar. And then towards the end, you can select what connector type that you want. As you can see on there, we've got some options for single M12 power and data if they wanted to have it in a star topology, a single 4-pin or a 5-pin 7/8 connector if they wanted to have it in 7/8 cable in that star topology, or we could offer that power over Ethernet option. I think it was Derek that asked in the questions about PoE. The PoE part number would be PF25 for the connectors at the bottom. In terms of just wrapping up where we are with this, hopefully that was of interest and hopefully it's piqued some questions. If you do need support, and do let us know, feel free to get in contact with your local Fortress representative, or if you're just handling some Profinet or Ethernet devices in future, please do know that GSDML files to help with your Profinet programming are available from Fortress. Your EDS files to help with Ethernet IP programming are available from Fortress. Your configuration instructions are basically a walkthrough of what's available. We actually now are just coming out with a software tool to allow people to identify and set devices a little bit easier. That's something that's available. And then those memory maps, which are like that virtual terminal arrangement we discussed today, they can be generated for custom Ethernet IP configurations on request, and they can be provided just like a wiring diagram to help controls engineers out there understand how they can program their units. And then any further questions that are required over technical support can be asked on technical.support@fortressinterlocks.com. Then just to wrap up, when are we next hosting? Hopefully today's been interesting for some of you, and if you do want to pass it on to your colleagues, because we sold out and we reached over our maximum registration limit for this webinar, we are hosting another one on the 22nd and the 17th of April. The one on the 17th of April is available at 10 a.m. UK time, so possibly a bit early for those joining us in America. The one on the 22nd of April is at 9 a.m. Pacific, 11 a.m. Central, 12 p.m. Eastern, which should be the same time as this one was on today. So that's not next Wednesday, it's the Wednesday after, I believe, for anyone that's interested in passing this on to their colleagues. The thing I'd encourage, if people are interested in our series of webinars, which include some product-specific ones, some standard-specific ones, and some application-specific ones, do go and follow Fortress Interlocks on LinkedIn, because we will post what our webinar schedule is on there. We'll have it as a sticky post right at the top of the Fortress Interlock page, and we'll post regular updates to promote what we're doing during COVID-19 to make sure that Fortress is still available for communication. And at that point, thanks all for all listening, and we'll wrap up on probably some questions that we've had come in.
I think we can do 2 or 3 here, Rob. I think I may have solved my internet problems here. So we have one question: is any of this available in the S40 series?
So one of the things to consider there for the S40 series, it's not available in the S40 series. For those not familiar with the S40 series, that is a stainless steel 40mm wide variant of our interlocking devices. We can't fit the physical size of the ProNet module inside that 40mm wide body, but we can provide a control station that maybe they can mount a little bit further away from the corrosive environment or the washdown environment, and then provide that network connection to the ProNet control station, and then a hardwired connection out of that I/O block stack offering into the bottom of the device.
And another interesting one, given some of the work we're doing in product development, has any of this been tested for placing in hazardous areas?
So we don't have these if we're considering hazardous area. It's like a atmosphere's explosible and ATEX, or I'm trying to think of in Korea it's a kosher rating, and I can't think off the top of my head of the US explosion proof standard. These currently aren't approved for a hazardous area. We haven't done any testing on it, but we have done testing down to negative temperatures and similar for those more extreme environments. We have done some testing down to negative 25 degrees and similar, but not for an atmosphere that's explosible at the moment.
And I think you're going to like this final question because it's a subject close to your heart. But have we done anything with safe radar and networks? So
we have. So like you said, this is close to my heart. So actually, that's something that'll appear in probably the Fortress Frank webinar that's available. What we've done with some safety radar signals is, because you can buy some safe radar that's all available for a hardwired connection currently. We've had a few customers that have had an interlock device, and what they've wanted to do, they've wanted to use that third dual channel safety input available on their device. They've had an e-stop in the device, they've had the guard locked and closed signal, but they've used that third safety input to go into their safe radar, which prevents unexpected startup while people are inside that area. So they're really just using the full maximized ability of a Fortress Ethernet device to connect into a radar system that supplements the guard locking technology.